Hello, good afternoon, everybody. This is the first ever PinCon, that is the Pipeline Integrity Conference. Welcome, everybody. I'll be talking about the subject called Utilization of High Resolution Integrated Indirect Inspection Survey Technologies as part of the direct assessment methodology of aging non-CP protected pipeline network. We're going to be talking about pipelines which are not cathodically protected, and these are upstream pipelines that we'll be talking about. I'm going forward now. That's my introduction. I'm directly going into the subject of this presentation, which is talking about the network of the client, which includes a rich gas pipeline network of around 31 pipelines, 185 kilometers, lean gas pipeline network, 3 pipelines, around 37 kilometers, and gas lift pipelines, 8 numbers of around 94 kilometers, and of course, crude oil delivery pipelines. In total, there were total 50 pipelines or so of more than 400 plus kilometers. Uh, None of them are CP protected, but they were designed to be so. So it's not, they were intentionally not to be put in categories, is that the CP system not working. It was designed not to be CP protected, so it's okay. And these are upstream pipelines, and these are also designed on a temporary basis. And these pipelines are pretty old. Some of them go back to 1975, which is almost 45 years old, to even recent pipelines, which in some sections in some pipelines have also been replaced, which could be replaced in last 2018 or something that we have records of. The kind of pipeline that we're talking about is it's an upstream pipeline network. It's temporary pipeline systems, as already mentioned before. They are all non-CP protected, and it's highly clustered. Of course, we'll show some photographs so that you get an idea of what kind of pipeline we're talking about in this particular case. But what the client needed in this case was they needed a technology that could be used to isolate and map these kind of pipelines, which is the key of and key subject of this presentation, and we're going forward based on that. Some live examples of such pipeline network is some photograph that we're talking about here. All the pipelines are together. Some of them does not have coating, some of them does have coating. They are all going together like this on bridges like this. Some of them are bigger diameters, some of them are smaller diameters, some of them are touching each other. They're all steel pipelines, mind you. So each steel pipeline touching each other, it means that they are all electrically continuous. One more example of this. Sometimes the pipeline comes above ground on its own and then goes underground again. Something like this that we're seeing over here. It's because the soil in that area have subsided, or maybe just general erosion of the soil has occurred due to in a lot of precipitation in the area. Again, some examples like this, and some of them are also, it could be such a case that one pipeline within that whole bunch was laid maybe 2 years ago, and another pipeline was laid maybe 30 years ago. So that could also be the case in this area. Another photograph of our guys doing the survey. What are the key properties of these lines? Minimal coating left. It was not designed to be CP protected, and because they are all together and touching each other, and there is no insulation joints at the stations, they are all electrically continuous. And to actually assess the integrity of such pipelines, whoever the contractor is or anybody in the future as well, they need to have a tool that can actually isolate these pipelines from each other, so each of these pipelines can be identified so we can assess them accordingly. What are different surveys used during this indirect inspection survey? During this process is what we have to do is we'll be using a technology called XLI in this particular case, in this particular project. And that's how we do the survey with two guys side by side. parallel to each other. One guy has a line locator and on the GPS backpack, and the other guy has the probe for recording all the readings. And these are all the items that are being collected at the same time in this particular case. So we have to be collecting all of them to ensure we have enough data to assess integrity after end of this program. So we are collecting GPS, we're collecting continuous depth of cover, which is also very important for ICDA programs. We're collecting native SIPs. It's not normal SIPs. Normal SIPs would have been in the case of CP protected pipelines. But in this case, we are collecting what the native potential is of the pipeline. That is what kind of potential is the line seeing from the environment as it is without any in place impressed current cathodic protection or a sacrificial anode cathodic protection system. We're not doing any DC kind of a survey. We're not doing DCVG. So we're doing ACCA in place of that as well as ACVG. The survey, after we complete the survey, this is how it looks on the software, and these are the different data sets that we collect on the same time, and it's aligned automatically. So we get native SEPs, we get the CAT data, we get the ACVG data, we get the elevation data, we get the depth of cover continuously data, and of course the plan view with all the lat longs and everything. What that does is after you finish a survey like this for many of these pipelines, which we have done in this particular case, imagine the kind of pipelines we just saw a couple of slides ago when all of them are touching and all of them are crisscrossing each other. Finally, you get to a point where we can isolate and have them map like this. This is operator's dream come true for such a case. I mean, having this done for non-CP protected pipelines, that too in a situation where all the pipelines are touching each other and all together. So this is quite a unique feature and something that takes a lot of time and effort, but it can be done if the right technology is deployed. So we'll be talking about the results of this kind of a survey that was deployed for this kind of a program. So therefore, we'll be talking right now of the readings as well as what was actually found during the inspection, the verification inspection process. So this is one location at 221 meters. We have high attenuation and a peak ACVG fault as shown there. And this is how we see it in the field. We see a coating holiday, another coating holiday, and underneath the coating holiday, we are seeing a lot of external corrosion, pitting external corrosion. So we're actually finding out corrosion from these kind of surveys. So if you see from the NACE perspective of the NACE ECD standards, any of these above ground survey technologies, they are not directly or they are not supposed to be finding you external corrosion. They're supposed to be finding you indications. What is an indication? As per NACE, an indication is anything out of the norm, which is picked up and which is electromagnetic in nature, and it's picked up by the above ground survey that was done earlier. But in this case, we are pretty lucky. We found holidays and we found associated external corrosion along with the holidays, and we could categorize them accordingly. So which is quite a successful process during this project. Another example is we see an indication which has been ACVG flagged. this is quite startling even for us, even though we've been using this technology for quite a while now. We find a welded plate which had previously must have been a repair in this area. If you can see where my mouse is, another holiday and long holiday. And additionally, we are also finding a leak. This was a live leak. After we removed the coating in that particular site, we actually find a leak, and we had tested this with bubbles to see that the leak was incoming. I mean outgoing. Sorry, it was outgoing in that particular case. So we could We actually stopped a catastrophe in that area because we find a leak by using indirect inspection technology. That is quite something, because again, I would like to reiterate, we are not supposed to be finding leaks through doing indirect inspection technologies. DA as a technology is meant for finding metal loss. It is not meant for finding leaks. But sometimes the data connects and it does make sense. The science makes sense, and we end up picking up the right location for finding leaks like this. In another location, we find we have caught an indication which was flagged as a coating anomaly by ACVG. But of course, when you do the excavation, then we see that it was not exactly a coating anomaly. It was a coal tar coated pipeline, and the clamp on which there was a leak before. It was the client had repaired the leak using a clamp, and the clamp was left bare. Therefore, our technology, the machine that we had deployed, it saw that particular clamp, the bare clamp, as an indication which got flagged during our data assessment, and therefore could catch it. And this is again something quite amazing, because even for us, as we have been doing this kind of surveys, and it's difficult to see something like this in the by using indirect inspection technologies. This is another example. We see a coating holiday. What we're trying to show is, you see a holiday like this and you open up the coating, and then you see that the coating is moving away from the pipe, which is known as disbonding. So the coating is moving away because of disbondment, and you know why it is disbonding. It's because based on the holiday, the area started corroding. So the deposits have created the coating to be disbonded off from the pipe, uh, so that the coating is just sitting on the pipe, but it's not exactly adhered to the pipe. This is another example where we're talking about, okay, this is another case. So in the same, in these old pipeline systems that I'm talking about here, where some of the pipelines are more than 45 years old, some sections, because of previous historical problems, some sections were replaced. And now that the industry has moved on to 3LP type coating, those replaced section was 3LP coating. Even though the pipe material is the same, but the coating is different. The original coating was coal tar, but now the replaced section has been 3LP. But even in this area, we could still see holidays, and something like this was caught. And if you see the attenuation in the area, it's less compared to the coal tar attenuation that we saw earlier, couple of slides before this. So this makes sense, because this makes scientific sense as well, because the 3LP coating is in place exactly. It's not degrading like the coal tar coating is. Plus, we know it's new coating, therefore it's not supposed to be losing out on attenuation. But still, there was a holiday which was most probably caused by a third-party defect or something, and which was caught by the program. And we had removed it and also checked for disbondment, which we found a little bit of disbondment, even though this replaced section was only 2 years old. This is another example that we're talking about. In this case, it's moderate DOC. Depth of cover is less, which is what it means. Minor ACVG and no attenuation. So what in this case we're trying to show to the audience here is, we're trying to show whether this program will also work for a location where there is no indication, to prove the kind of a null site per se, where because we have to also show that if this if the technology is not catching something, does it mean we are missing something? No. So just to prove that, we've got this slide in, and this is what we're going to talk about here. So this was in particular a null site, and after excavation, that is what we find. We find perfect coating in the area. There was one pipeline crossing on top of it, and we see that the subject pipeline which was being surveyed, that pipeline did not have any coating anomalies, nor does it have any problems. Although the pipeline on top, which the one which is crossing, those had couple of coating holidays, and most probably the ACVD minor indication that we got in this location could have probably come from this pipeline, which is crossing over our subject pipeline in this particular case. So this was quite impressive, and with this, I come to an end that when you do such niche, old pipeline system, and when your pipeline system is critical to be assessed, you might require for additional indirect inspection technologies. You cannot just hope that two will do it for me or one will do it for me. You'll have to go for maximum resolution, which is the subject of this presentation. And that's how I close this topic for the day. Thank you. And if please let me know if you have any questions.